Hello students, I hope your preparations are going well. Today we are going to discuss a very important concept of number system, factors advanced. Before starting this session, let's have overview. First of all, we will discuss some advanced questions on factors. Then we will learn how to solve equations by using factors. Then you will have some practice questions and the answer key. This is the very first question. N is set of all factors of 3 raised to power 5 into 7 square into 5 cube. M is set of all factors of 3 raised to power 4 into 7 cube into 5 raised to power 1. We want to find number of elements in N intersection M, and the second part is N union M. So let us start. See, N is set of all factors of 3 raised to power 5 into 7 square into 5 cube. So what is my first number? This is 3 raised to power 5 into 7 square into 5 cube. What is the second number? This is 3 raised to power 4 into 7 cube into 5 raised to power 1. The very first part, we want to find number of elements in N intersection M. Now we can take this number 3 raised to power 4 into 7 square into 5 raised to power 1. See what is the logic. First of all, we are taking this prime 3. We are considering both the powers 5 and 4. We are taking least of that. Similarly, in 7 the least power will be 2. In 5 the least power will be 1. So we have taken a number which is common to both these numbers. So we will find the number of elements, number of factors of this number. By using formula, we can write 4 plus 1 into 2 plus 1 into 1 plus 1, which comes out to be 5 into 3 into 2, which is equal to 30. That's why this is the answer. So there will be 30 factors, which will be both the factors of N as well as M. Now come to the second part. We want to find the number of elements in N union M. We know this formula that N union M is N plus M minus N intersection M. We can take this formula in number of elements as well. I mean, number of elements in N union M will be equal to number of elements in N plus number of elements in M minus number of elements in N intersection M. By using formula once again we can do this. Now in N, how many number of elements are here? There will be 6 into 3 into 4 plus 5 into 4 into 2 minus now number of elements in N intersection M that we have calculated in the first part, which was 30. So if you solve it, you will get 82. That will be the answer for the second part. Let us move to next question. N is set of all factors of 3 raised to power 5 into 7 square into 5 cube. M set of all factors of 3 raised to power 4 into 7 cube into 5 raised to power 1. We want to find product of all the elements of N intersection M and N union M. See, first of all, you must know this formula. What is product of all the factors? It will be number itself raised to power total number of factors divided by 2. This formula is applicable everywhere. So what is N here? Set of all factors of 3 raised to power 5 into 7 square into 5 cube. Similarly, we have M. First of all, the very first part, we want to calculate the product of all the elements of N intersection M. Once again, I'll take that number which will be common to those given two numbers, and that will be 3 raised to power 4 into 7 raised to power 2 into 5 raised to power 1. So we can apply the product formula. So product will be the number itself raised to power total number of factors divided by 2, which comes out to be 3 raised to power 60 into 5 raised to power 15 into 7 raised to power 30. And this will be the answer for first part. Let us move to second part. In this part, we want to calculate product of all the elements of n union m. Once again, first of all, we will write product of all the elements of n. So, which comes out to be 3 raised to power 5 into 7 square into 5 cube. Again, using the product formula into, now we will write product of all the elements of m. It will be 3 raised to power 4 into 7 cube into 5 raised to power 1. Product formula now, 5 into 4 into 2 divided by 2. But in this product, we have calculated many factors twice. Obviously, they are factors which are appearing in n intersection m. So, we will divide to nullify this effect. So, it will be 3 raised to power 4, 5 raised to power 1 into 7 square raised to power 5 into 2 into 3 divided by 2. So, if you solve this, you will get the answer. Now, what is the answer here? By solving this, you will get 3 raised to power 200 into 7 raised to power 102 into 5 raised to power 113. So, this is the answer in this case. I hope the question is clear now. Now, the next question. It says, let n is equal to 3 raised to power 15 into 7 raised to power 43. How many factors of n square are less than n but don't divide n completely? So, let us see. Before explaining this question, let us take a smaller example. Instead of this n, suppose my number is 6. What is n square then? 36. Now 6 can be written as 2 into 3 and 36 can be written as 2 square into 3 square. Once again, I'm coming to the question. What was the question here? How many factors of n square are less than n but don't divide n completely? So, if we take n square here, which is 36, and we write the factorization, the first we will get 1 into 36, then we will take 2 into 18. See, I'm writing the smaller number on left hand side and the bigger number on right hand side. The next will be 3 into 12, the next will be 4 into 9, and the next will be 6 into 6. So that is the list of all factors of 36. But as you can see, 6 is coming twice. So if we find factors of 36 by using formula, it will be 2 plus 1 into 2 plus 1, which comes out to be 9. But in this complete list, we are writing a factor twice. That's why corresponding to that, I'm writing plus 1 to 9, which comes out to be 10. I mean, this 10 will represent the number of factors appearing in this list. Now, what was the question? How many factors of n square are less than n? It means we are interested only on the left hand side, which is 1, 2, 3, 4 and 6. So, instead of calculating this, we can do one more thing. See, 10 factors we are getting and we are making pairs. And how many pairs can be made out of 10 factors? It will be 10 by 2, which comes out to be 5. As you can see, there are 5 terms here, and corresponding to every pair, we will take only one number which is appearing on the left hand side. Now, out of these 5 numbers, we don't want those numbers which are dividing n completely. So, we are not interested in 1, 2, 3 and 6. So, we are left with this 4. So, what is the answer in this case? It will be 1. Instead of counting all this, let us use the formula. How many factors of n are here? They will be 1 plus 1 into 1 plus 1, which will be 5 minus 4, 1. So, this will be the answer in this case, because this one will be correspond to 4. Now, let us take the same application in the sum. Now, what is n here? 3 raised to power 15 into 7 raised to power 43. What will be n square? It will be 3 raised to power 30 into 7 raised to power 86. How many factors of n? They will be 15 plus 1 into 43 plus 1, which is 16 into 44. How many factors of n square? They will be 30 plus 1 into 86 plus 1, 31 into 87. Because n square can be written as n into n. So, in writing all the factors, we will repeat n. Corresponding to that, I am taking 31 into 87, that is the total number of factors of n square. I'm adding 1 and I'm dividing it by 2. Why? Because we were taking pairs. So we will get the left hand side only. Out of these numbers, we are not interested in factors of n. That's why we will subtract 16 into 44, which comes out to be 645 in this case. And this is the answer. Now one shortcut for this question, because I have seen this question many times in many papers. Directly, what is the answer to this question? That will be the multiplication of the powers. By using the same theory, we can prove this. So what will be the answer? It will be 15 into 43, which comes out to be once again 645. Now the next question. It says find number of positive integral solutions of x square minus y square is equal to 840. See, how can we solve this question by using factor theory? Instead of taking 840, I am taking a smaller number, x square minus y square. Let us take, instead of 840, we will take 15 suppose. And we want to find number of positive integral solution. See, x square minus y square, by using algebra, we can write x minus y into x plus y is equal to 15. Since x and y, they both are positive integers, of course, x minus y, x plus y, they should be positive integer always. So, x should be more than y. Now, 15 can be written as 1 into 15. It can be written as 3 into 5 as well. So, if we take x minus y as 1 and x plus y as 15, it will give you one solution corresponding to x and y. Let us solve. Let us take x minus y as 1 and x plus y as 15. By adding two equations, y will get cancelled. We will get the value of x, which comes out to be 8. And y will be 7 in this case. That corresponding to one solution. Now coming to second solution, if we take x minus y as 3 and x plus y as 5. If we solve it, we will get x as 4 and y as 1. So we are getting two solutions. Now, how can we use factors here? Instead of solving all these things, see, we want to find number of positive integral solution. We don't want to find solutions. That's why we can see that 15. How many factors of 15 are here? 15 can be written as 3 into 5. So how many factors? There will be 2 into 2, which comes out to be 4. So 15 has 4 factors. And see here, we are making pairs of 4 factors. How many pairs can be made? It will be 4 by 2. So what is the answer in this case? 2. So what is the question now? It says in how many ways 15 can be factorized into 2 factors. It can be factored into 2 ways. That's why corresponding to that we have 2 solutions. Once again, I'm taking one more number. Say instead of 15, let us take 30. Now 30 can be written as 2 into 3 into 5. If we solve it in the same manner, we will get x minus y, x plus y is equal to 30. Now 30 can be written as 1 into 30, 2 into 15, 3 into 10. Then we can write it as 5 into 6. Now, if we try to solve it, see, I am taking the very first representation. Let us take x minus y as 1, x plus y as 30. If we solve that, we will get x as 31 by 2, which is not an integer. That's why this solution is not possible. If you see it closely, in every case, solution is not possible. See why so? As you can see, whenever we are solving these equations, we are getting, if we add these two equations, we will get 2x is equal to 15 plus 2. So what will be the solution here? X is equal to 15 plus 2 by 2. So if we want x to be an integer and y to be an integer, these two things, they should either be even or they both should be odd. Because in these two cases only, the addition of these two numbers will be even always. Then only we will be able to divide it by 2. So we can see, whenever you are taking this equation, either the number on right hand side, it should be an odd or it should be an multiple of 4. Because in that case only, this equation will be solvable. So let us coming to original question, it was x square minus y square is equal to 840. Now 840 can be written as 2 cube into 3 raised to power 1 into 7 raised to power 1 into 5 raised to power 1. Now x square minus y square can be written as x minus y into x plus y. As you can see, this number is even. That's why these two numbers should be even always, because in that case only we'll be able to divide it x by 2. So we can see these two expressions should be even always. We can do one thing now. To make them even, we can take two 2's from 2 cube. We can assign 1 2 to x minus y. We can assign 1 2 to x plus y. So x minus y, x plus y, they will become even always. If we have taken two 2's from 2 cube, so we are left with 2 raised to power 1 into 3 raised to power 1 into 7 raised to power 1 into 5 raised to power 1. Now there is no problem because already we have made x minus y and x plus y even. So what we can do now? Directly we can take this number and we can see in how many ways can this be factorized into two factors. How many factors are here now? It will be 1 plus 1, 1 plus 1, 1 plus 1, 1 plus 1. It will be 2 raised to power 4, which comes out to be 16. It means the new number has 16 factors and we want to make pairs. So pairing can be done in 16 by 2, that is 8 ways, and corresponding to every way we have a solution. See, what was the thing here? We were not interested in finding solutions, rather we want to find the number of solutions here. That's why we are not finding solutions, rather seeing how many pairs are possible. So what is the answer in this case? It will be 8. Now one more question on the similar concept. From first 1000 natural numbers, how many numbers can be written as difference of two perfect square? If we formulate this question into an equation, it will become x square minus y square. That is the difference of two perfect square. That is a natural number. How many natural numbers will exist from 1 to 1000? As we have discussed that this equation will be solvable for positive integral solutions if on right hand side we have either odd number or a multiple of 4. Then only this equation is solvable. Otherwise, we'll be unable to find integral solutions. In that case, we will find fractions only. So, from 1 to 1000, how many odds are here? They are 1000 by 2, 500. And from 1 to 1000, how many numbers which are multiple of 4? Again, it will be 100 by 4, which comes out to be 250. So in total, how many numbers? There will be 750, and this is the answer for this question. I hope the idea is clear now. Now these are some practice questions, and this is the answer key. For more advanced concepts, you can make an account on hitbullseye.com. Okay guys, happy learning.